first math investigation lesson, okay? And I'm going to my book because I'm going to make sure that I'm giving you the right I can statement, okay? So I'm going to be able to use an arrays to make multiplication. And I'm going to determine whether one number is a factor or multiple of another. So we've got some vocabulary there. We've got multiplication, we've got multiple, and we've got factor, okay? So I want you to think about that. You're going to build arrays to help us think about numbers. If I wanted to build an array with 24 tiles, what dimensions could my array have? Okay, so think about this. You've got 24 tiles total, right? Mm-hmm. Now, I've got to come up with two dimensions that are going to make 24. Can you think of a way? Write it down in your notebook. You can write down your you can draw out the picture.
Do we have to draw like every single?
Oh, no. Do an unmarked array where you draw this. Just draw the rectangle and then put the dimensions around it. Okay. Do you have an answer? Mm-hmm. Okay. You have an answer? Mm-hmm. All right. You have an answer? Okay. You have an answer? Mm-hmm. All right. So, Alana, tell me two dimensions that will make.
Two problems or just one?
No, just one. I need one problem. Tell me that.
8 times 3.
8 times 3. Is she right, guys?
Mm-hmm.
Yeah. So one of the sides is 8. The other side is 3. So I would draw out 8 by 3. So I could actually draw on the tiles, but I'm going to wait. So 8 times 3 does equal 24. Okay. Kimmy, did somebody get a different set of dimensions? Mackenzie?
I did 12 times 2 equals 24.
Okay, so you did 12 times 2 equals 24. Did somebody do something different? Oh, Bethany, what did you do?
I did 6 times 4.
Yeah.
Okay, you did 6 times 4, y'all. Okay, that's another one. Sorry about my handwriting, it's hard. It is. Did anybody get anything different?
You could have done 7 times 4.
Yeah.
Wait, no.
Go ahead.
7 times.
Why can't I do 7 times 4?
Because you have the 23 when you do 7 times 3. Or no, you have the 21 when you do 7 times 3,
Yeah.
so you can add 7 and it would be 28.
Yeah, it's too much, because it wouldn't have 24 tiles. How many tiles would it have?
28.
28, yeah, and just a math mistake. Listen, I'm gonna make math mistakes all the time. I can hear your thinking. I love that I can hear your thinking. And I knew what you did because you shared it with all of us. And it's always okay to be wrong, because that's how I learned to be what? Right. You gotta take a risk. You gotta be willing to say, I don't know this, I need help. It's okay to be wrong. And when math gets harder, you're going to have to keep trying, right? Doing it over and over and over. So I love that I can hear your thinking. Good job. All right, so you did awesome with this. So here's what I want to do. I'm going to talk to you now about an unmarked array. I loved when you said, do I have to draw the boxes? Do you need them once you have your math multiplication tables memorized?
No.
Those are for people that need to do what?
Like, and if you needed to do it, you don't even need to draw all of them. You just draw like 8 times 3, you do 8 on the top and then 3 right there.
You are so smart. Gosh, you're pretty and smart. Wow. Okay, so here we go. I'm going to teach you and talk to you about drawing an unmarked array, okay? So draw your box. and this is exactly, you already did this without me telling you that. And we'll talk about the example you just said. Because she used what she learned in Quick Images she transferred it over to this. She said, well, so let's do this. I'm gonna have a dimension of 8. And I'm gonna have a dimension of what? 3. Okay, what is it total on the inside? How many tiles would be there?
24.
Okay, you told me that. Now, Alana said, I don't technically have to draw out all of those. She said I could do 3 circles. And then how many do I need going across, y'all? 8. So I've already got 1 drawn. How many do I put? 7. You guys are geniuses. Gosh, this is the best class I've ever had. Just kidding, guys. You people that are in my class this year, you're the best class I've ever had. So she used that strategy, right, guys?
Yeah.
She did, and that's a strategy because that's how her mind was thinking. She was using that quick image to let her see the math, okay? Now, that's called an unmarked array. You people don't need it anymore. So now when we're working out things, when the math gets higher, when we start dealing with the 12s, and you have grid paper, you get so high, you actually can't draw out an array anymore. Does that make sense?
Yeah.
The paper doesn't fit the mathematics anymore. So now, use an unmarked array. So let's do this problem, one more problem. I'm gonna give you a hard one. Let's see. What is it?
108.
How'd you know that?
9 times 10 equals 90. 9 times 2 equals 18. Yeah, that's, yeah.
So you did a breaker part problem. You actually took a math fact that you knew and you broke apart the mathematics, right? So you're thinking, you saw, remember what the math. How many ones did I have there, Cody? How many ones are here?
2.
2. How many 10s do I have?
10.
10. Yeah, 1 10. 1 10 is 10. And you can now know 2 times 9 is what?
18.
18. Is this what you said you did in your head that way? And then you did 10, right? Times what? 9 is what?
90.
90. And then 90 and 18 is what? 108. Yeah, you can break math apart in your head. Bethany?
So what I did, I kind of either know the math fact, or I just do the algorithm.
Yeah, algorithm. Once you have those math multiplication facts memorized, you just know the answer. And that's why those math facts are so important that we memorize them, because then it's automatic. I mean, it's so easy in your head. You're like, 12 times 9, 108. I mean, Mackenzie, what did you do?
What I did was I knew that 12 times 8 was 96, so then I just added 10 and then added 2.
Who taught you how to do that?
You.
Yes! Woo! I'm a good teacher, aren't I?
Yeah.
I love you guys. Okay, so let's go on. We are going to be looking at a number puzzle, okay? And you are going to need to get your paper that we pulled out earlier on your desk. Now, in Gaston County Schools, this is the model that, even for y'all, that they're going to be teaching by. You've got, have they told you this yet? Teach it, practice it, evidence, right? Teach it, practice, evidence. And so we just did the teach it part, right? We practiced because you did what? So this is gonna be the evidence part of it. Now, we gotta go over a few things before we start. We're gonna be making a number puzzle, okay? And a number puzzle will make an array that has 10 as one of the dimensions. Now, we're gonna do a practice before you start this sheet, okay? So we're gonna be doing number puzzles, and we're gonna do a practice. So let me clear this real quick. Okay. Does it bother you that's over here? Okay, thank you, because it's hard. Thank you for being kind to me. Okay, so I'm gonna pick a pretty color too. I'm gonna give you a puzzle clue. Now, the number is going to make an array that has 10 as one of the dimensions, okay? So let me go to the book. We have just listed factors of 24. What are some multiples of 24? Sometimes people confuse factors and multiples. What are ways that we can remember which are factors and which are multiples? So I made an anchor chart for us, and here it is. I'm sorry it's far away, but can y'all see it? Okay, so we're going to talk about factors first. And factors are in pink, and so everything in this pink is a rule of a factor. So a factor is factors of numbers are the sides of rectangles with that number of tiles. So let me read that again. Factors of a number are the sides of rectangles with that number of tiles. Okay, that's a rule. Here's another one. Factors of 24. 1's a factor, 2, 3, 4, 6, 8, 12, 24. So those are factors. When you multiply the factors of a number, they equal that number. You find factors on the calculator by dividing. That's a different way to use it. We get to use a tool, the calculator. A factor is a number that fits into another number evenly. All of those are the rules that make up factors, okay? Now this anchor chart will be up all year. Now virtually, I'm going to take a picture of it and upload it for you, okay? Now multiples. A multiple of a number are what you say when you count by that number. So, multiples of 24. 24, 48, 72, 96, 120, 144. Why is 24 the first number? Mackenzie?
Because it's like, you can multiply 24 times 2 and you can get 48, and then you can do like 48, or you add 24 to 48 and then you can get 72.
So everything you said's right, but why is 24 first? Alana?
Because if you do 24 times 1.
Yeah, that's the first and last factor. You're right as far as, she said you start with 1 times 24. Let's make it real easy. That's the number we're counting by. So no matter what the number is you're counting by, it's always going to be first. If it was 3, and I'm counting by 3s, what would be my first number? 3, 3, 6, 9, right? 5, let's count by 5s. We ready? 5, 10, 15, 20. Yeah, so let's make multiples easy. Whatever the number is, I'm counting by that number. So that's just trying to make it an easy way to remember. So multiples are the times a number. And this is what you said. This is exactly, Mackenzie, what you were saying. Multiples are times a number, and you keep on going. Now let's go back to Cody and quick images. He was doing addition, and he was getting the right answer because multiplication is repeated addition, okay? So let's go on to finish the lesson here. So let's go back on track. Now, I do want to point out that there are wonderful resources on Pearson, but I don't know if we're going to be able to use them or not. The ITFs and everybody are still trying to work this out. But right here are videos that you can watch if you forgot what a factor is, if you forgot what a multiple is, for multiplication and division, and for arrays and unmarked arrays. So let's just look at one real quick. Now, the good news is that it'll read it to us, so let's look.
Arrays and unmarked arrays. Math words. Array. Dimension. An array is one way to represent multiplication. When we talk about the size of an array, we say that the dimensions are 5 by 9 or 9 by 5, depending on how you were looking at the array.
So you would have that to refresh your, is that a reteach? Yeah, that actually just retaught what we're actually doing. So you actually, so let's say we're struggling at something, right? I can go back to the videos over and over and over, can I? So if you don't get it the first time, what do you think you should do? Watch it again. So let's look at multiples, because that people get confused with multiples. Let's see how they teach that. Oh, I love this. Look what they've got. They've got the hundreds board. Y'all remember using the hundreds board? Yeah, I love it. Okay, so let's go. Ready?
Multiples. Math word, multiples. This 100 chart shows skip counting by 8. The shaded numbers are multiples of 8. A store sells shirts for $8 each. One shirt costs $8. 2 shirts cost $16. 3 shirts cost $24. 4 shirts cost $32.
So, and look how, why do you think it's doing this on the hundreds grid? The hundreds board? See how it links up?
Yeah.
I just want you to think about that, okay? Just think about that. Maybe you'll see it. Okay, so anyway, you've got these cool videos that when I forget, I can go back and look. And that's going to help us a lot, isn't it, guys? Yeah. And you can re-watch the teaching with me if you wanted to. So you can re-watch the video. So let's finish this lesson. We're going to go back to this. So an unmarked array, the number will make an array that has 10 as one of the dimensions. So you are actually going to draw an unmarked array. Let me get to my, be patient with me, so I pull up all these slides. Oh, well, if Ms. Jenkins, use your resources, look. Here it is, number, no, that might be the first one. I have to look.
That's the right one, I think.
Yeah. That's the one in our paper.
Yeah, it says not to focus.
Yeah, there's, but it's not coming up. It's making me sign in. Okay, so it got crazy. Hold on a minute. You know how it is with technology, it doesn't always work. We'll try again. See, it's okay. When technology fails, we're gonna have to do something else. Okay, so let's do this, because you guys have got it. You're gonna make an array, so unmarked array, and one of the dimensions has to be 10. So just make me some arrays that, an unmarked array, one of the dimensions has to be 10. So just on your paper, oh, well, in your math notebook right now, in your math notebook. Because I don't think the paper's the first one, is it? No, it's not. Okay. So just real quick, do as many as you can. So do me some unmarked arrays with one of the dimensions as 10. go on, because we don't have forever, okay? So give me a dimension, give me an array, okay, Mackenzie?
I did 10 times 5,
Since you did 10 times 5, and what did you get as the answer?
50.
50. Okay, a different one, Cody, what'd you do?
10 times 4,
10 times 4, what's your answer?
40.
40. A different one, Alana?
I got 7 times
7 times 10, and what is that?
70.
70. A different one, Bethany?
I did 10 times 8, and I got 80.
10 times 8. And you got 80. Now, what do we notice? Can we notice anything? Okay, Bethany?
They all have zeros at the end.
Okay, why is that?
It's because they all, well, 10, if you times anything by 10, it's always gonna have a 0, because it's just like, it's easier to, but,
It's a multiple of 10, right?
yeah.
Okay, I know your math brain. I hear what you're trying to tell us. These are multiples of 10, okay? And we love multiples of 10 because you're right. All I have to do is tell me how I can figure it out.
Well, what you could do too is just say, if you could say 1 times 5 is 5, and then just add the 0 to the end.
Is she right, guys?
Yeah, that's the
Yeah, that's why. You're 100% correct. That's a multiple of 10. And you're right, multiples of 10, we can find a shortcut. 1 times 5 is 5, add a 0. 7 times 1 is 1. Look what I did.
Yeah.
What did I do?
10.
You got 10.
10.
What is the answer?
70.
I told you I'm gonna mess up all year long, okay? All right, now, you're ready to do your paper, okay? So, again, Gaston County Schools, you do a teach it. Okay, I taught, right?
Practice.
Do we just practice? Now, this is the evidence. This is where you prove it. This is where you're showing me the money that you learned what I taught, okay? So go ahead and start, please. And go ahead and do the whole sheet, okay? Yeah, you're gonna do the whole sheet, because this is evidence. Yes, you gotta put it there to both sides. Yes. Sorry, I didn't give you directions. I just realized I made a mistake because I didn't go over the directions with you. How did y'all figure it out? Mackenzie?
We pretty much are doing the same thing that we just did, like, just a minute ago, where we do, like, we have to do an array that has 2 in it, or, like, 5 in it.
Okay. What's something you should have done though? Bethany?
Well, what I did for the first one, it had to do with 2 in it, so I just said 2 times 9, and I just drew up my box, I said 2, and then put 9 at the top, and then just put 18, and then when it says number, I said 18.
Absolutely. You're solving it, but did anybody take the time to read the directions?
Yeah, I did.
Okay, so you gotta read the directions, because I didn't read it out loud. But you, like you said, you paid such attention during the lesson, you already knew what to do.
Yeah.
So I'm sorry I did not read the directions with you, but you're not gonna have me at home. So find 2 numbers that will fit each clue, draw unmarked arrays, and label the dimensions to show that your number fits the clue. List other numbers that also fit the clue. Now, number 1, the number of tiles will make an array that is 2 tiles wide. And everything y'all said was correct, but we forgot to read the directions, didn't we? Good job, keep going. You know, I'm a clock. I set the clock. How much time do you think we need?
5 minutes. 10 minutes. Oh, we're doing the back too.
Yeah, both sides. What do you
I'll
think?
let 10 minutes.
10 minutes? Okay, let's set a clock. Is that I think that you can be done in 10 minutes too. Do y'all like the music, or is it bothering you? Is that good? Music, okay. Now I'm gonna put my mask on, so if you need me for anything, you'll be safe, okay? So let me get a mask. That means you can keep going on and on, doesn't it? That if you have one of the dimensions that are too wide, say this is correct and this is correct, okay? No, just do a few examples. You got it, so let me check your.
I just didn't know if it was like the ends, right?
Yes, ma'am. I'm so impressed. Okay, so read the directions, Jenny. That right down here, the one you're looking at. So I'm only gonna have one array, there's nothing but one array. I can't make any other arrays. So there's only one array. So give me an example. Just put what you have here. So remember what we were talking about when we just looked at the square array? What did Cody discover when we actually saw the perfect square in quick images? Remember how people were saying, I just see it and it forms a square? What do you notice when it forms a square? You do, but when an array always makes a perfect square, there's rules. So do you notice anything about that when there's but the shape makes a square, right? Think about the dimensions of it. Or can you give me an example? Okay, so what do you notice about the dimensions? They're the same. You see it? So tell me another example. 5 times 5. Tell me another example. 6 times 6. You got it. Love that math brain. You got it. You rocking it. You rocking it. want you to find the numbers. Well, there's no other factors for it. So it's only got one array. Go back and flip your paper over and let me see what you got for that one. So what do you notice about this? That's correct. That's true. And what do you notice about this? So you're telling me that, I want you to think, because you're gonna go up to 50 and tell me the equations, right? That are like this. Just want you to think about it a little bit. Look at this. You're gonna tell me, flip your paper over. I want you to think about, let me read it again. Let's read it again one more time. There are some numbers that can be made into only one array. You showed me two different equations and they only make one array, and your equations are correct. Now they want you to show all of the ones that go up to the number 50.
Like the as and fifty?
Mm-mm.
Like
Counting up, like counting up to 50. So flip your paper back over. You showed me 1 times 4. So that's the number 4. You showed me 1 times 3. That's the number 3. So they want me to do that up to,
Oh.
well, explain, so read, tell me what you think it means now.
That you do like 1 times 1, 2 times 1 is 2, 2 times 1 is 3 times 1 is 3. Do it to all of them?
No, because you got it now. You let me hear your thinking, so I understand that you understand. We done?
No.
Okay. But does it only have one array? Okay, let me see your math. Your math is correct. So now you just need to do it up to the number what? You got it. This one. What are the dimensions of that? I'm only gonna have one array, okay? So there's gonna be no other factors that can make that if there's only one array to it. Well, 5 times 5 is 25. Is there another way to make 25? Can somebody help him out? He says 25, but 5 times 5 is 25. Is there another set of factors that can make 25? What is it? 25 times 1. Remember, this is going to be only one array. Alana, can you give him a clue about what you said to me earlier? About what we discovered? About the one array? It always has to be what? 1 and what? Can somebody help explain that?
It's always going to be one number because, like, 1, that's how you make a straight array. You just have to do
So let me cut this off, because this is a great math talk we're having. Okay, so she said, say it again.
So it's always going to be 1 because 1 just makes a straight array across. So it's going to be, you could do like 1 times 4. And it says go all the way up to 50. So like you could do 1 times 8. It doesn't really matter. It just still has to be straight. When you can't do 2 times 8 because that would be 2 arrays together.
That's right, you have more factors than just 1 times 8. What's another set of factors would you have?
You could do 1, I have,
No, if we have the product of 8, you said we could do 1 times 8. What's another factor pair?
for 8 or,
Yeah, for 8.
oh, you could do,
I think I'm confusing you because I'm talking about 2 different things.
yeah.
Everything, we're gonna hit it back and summarize. So we're gonna summary now real quick.
Meaning like you could say 2 times 4 equals,
Yeah, that would be another factor pair.
Yeah.
Okay, so let's check our work. So, everybody, let's bring it back together. We're gonna summarize our lesson, okay? So, quickly, we worked good to the timer too. So, let me put mask back on. All right, so, here we go. We've got, give me number one. Flip your paper over number one. Okay, give me, it said, a number of these tiles will make an array that's 2 tiles wide, okay? So what did you pick, Mackenzie?
I put 7 times 10 equals 14.
You did 7 times what?
That was my second.
So you did 2 times 7 is 14. Okay, that's correct. Cody, what did you do?
I did 2 times 4.
That's correct. What did you do?
One of them I did 2 times 5.
That's correct. And what did you do?
2 times 8.
All of you are correct because one of the factors was 2. Okay? So all of you are right. Let's go on number 2. Let's look at that. The number of tiles will make an array that's 5 tiles wide. So Cody, what'd you do?
5 times 2.
5 times 2. Okay, another one, Mackenzie?
5 times 3.
Okay, so we've got this. All of you are right. Now here's the tricky one. This number of tiles will make only one array. Okay, so she just explained it to us. Could somebody else tell me what she just said? Were you listening to her when she did the math talk? Let's be honest. Were we really listening to her? A little bit. Can you say what she said?
She said that it only had to go one way.
Okay.
Like it's only one number?
Yeah.
It's like a straight. It's just a straight array.
Yeah,
You
straight
can't, like,
line.
you won't have 2 blocks over each other. You just have it all in one straight line.
You're exactly right. It's always going to be a straight array, and
And 1 times whatever.
1 times any number will always make a straight array. Do y'all remember what that vocabulary word is?
No.
Does anyone?
It also could be anyway. You could have it like all the way like to the top, to the bottom. You could have it.
Yeah,
side
it doesn't matter the way
to
it's
side.
turned,
Yeah.
but it's just going to have one array.
Yeah.
Correct. It can be going this way. It could be going this way. You're right. You could even turn it diagonal because so that word is going to. Y'all ready to remember this from the past? A blast from the past. Prime number.
Yeah.
Prime number. Yes. So a prime number has a rule. There's only 2 factors. 1 times its self. And you discovered it, so you got it. So let's flip our paper over. Okay. Okay. So the number of tiles that makes a square array. When we were doing quick images, y'all discovered it naturally. He did. I heard her do it. We got to it, didn't we? So somebody tell me the rule about a square number. Okay, Alana?
It's 2 of the same factors. Like
Yes.
It could be like 5 times 5 or 4
You
times
got it.
4.
4 times 4.
100 times 100.
100 times 100. You got it. If the same number, if it's both the same factors, it will always be a square array. If I have 1 million times 1 million, will it be a square array?
Yes.
Yes. Okay, you got it. Boom, let's go on. Okay? And so you got, we discussed this. We had this talk. You told me any number times 1 up to the number 50 counting is going to be correct.
Yeah, you could even have like 25 and 1 times 20.
Let's go back to number 4 again. Do y'all remember the term square number?
Yes.
Yes, so that's why it's called a square number.
Yeah.
A square number will be the same 2 factors. Okay, so make sure we're bringing out math vocabulary. Last one. There are some numbers that can make a square array. Find all the numbers that count up to 100.
So it's just like Thomas fortune.
Yeah, so give me some examples.
You could go 1, 2, 3, 4, 5. You could do 100 times 100.
Yeah, I could go 1 times 1, 2 times 2, 3 times 3, 4
Yeah.
times 4, 5 times 5. And it's really not that hard, but that seems intimidating, doesn't it?
Yeah.
It does, but once you understand it, it's like, just like she said, 100 times 100. So, if I'm listening, I'm learning, right? If I'm thinking, I'm learning. It's hard, isn't it? But if you talk it through, it can get confusing, but we have to do a lot of remembering, right? But you got it, didn't you? So y'all all made 100 on evidence. Good job. This lesson's over.